So for 7, 8, and 9, we're going to be looking at thermochemical equations. So some quick recap on chemical equations. The number before your elements is going to be your coefficient. Your coefficient is going to represent the number of moles that you have. Remember, if it's before the arrow, it is going into the reaction. If it's after the arrow, it's coming out of it. So these are your reactants, these are your products. Here, you see your change in enthalpy. If it's a negative number, that means you are losing this amount of energy. If it's a positive number, that means that an amount of energy is going into the equation. Okay, so let's get to it. It says how many moles of water are produced from the following reaction when 275 kilojoules of energy is given off. So you're always going to start with what you know. We are going to be setting up a T chart. So 275 kilojoules. Okay. In this case, they want moles. You need to get rid of this, so you're going to put the only other number that has this same unit, which is going to be this. So you are going to put 1,530. Okay? So what this is saying is that in this chemical reaction, anytime you have these numbers, you're going to get this amount of energy. So in this case, your problem wants moles of water. So moles of H2O. You have 6 here. So for every 6 moles of water that you have, you're going to get this amount of energy. So you're going to put 6 moles of H2O. So now you're just going to solve for it. So 275 kilojoules is going to cancel, divided by 1,530 times 6. And the reason I left out the negative is because you can't have negative moles. Okay, so our answer is going to be we're going to round it to 0.8 moles H2O. Okay. Number 8, it says how much energy is produced when 9.7 grams of oxygen reacts with 13.2 grams of hydrogen in the following reaction. For this particular problem, because they gave you 2 numbers, they gave you grams of oxygen and grams of hydrogen, this is going to be our limiting reactant problem. What this means is you're going to do what we just did, but twice, one for each compound. So let's start with oxygen. So we're going to start again with what we know, 93.5 grams of O2, and they want to know how much energy. Because we start with grams, we're always going to use the molar mass. So grams is going to be at the bottom. Oxygen has a molar mass of 14, but you got 2 of them. So this is going to be, no, oxygen is 16. So the molar mass is going to be 32 O2. That's going to give you 1 mole of oxygen. Okay? We need to get rid of 1 mole of oxygen, and the only way we can do that is by using our chemical equation. Here you have no number, which is going to be another 1 mole of O2. And for every mole of O2 you have, you're going to have this much energy. So negative 572 kilojoules. And you're going to solve for that. You're going to do 93.5 divided by 32 times negative 572. And you're going to end up with negative 1,671.3 kilojoules. In this case, you can put the negative because this is saying you're losing energy. The moles was different, but for energy, you can lose it. So this is our answer for oxygen. Now we have to do hydrogen. I'm going to use a different color just so it's easy to distinguish. So again, you start with what you have, 13.2 grams of H2. Again, you're going to need the molar mass. Hydrogen has molar mass of 1. You got 2 of them, so this is 2 grams of H2. That's going to give you 1 mole of H2. This cancels with this. Now you got to get rid of this 1 mole. So you're going to look to your chemical equation. Here it says you have a 2. So you have 2 moles of H2. And because you have 2 moles, you're going to make negative 572 kilojoules of energy, or you're going to lose that much. So now we plug it into the calculator. 13.2 divided by 2 times negative 572 divided by 2 is going to give you negative 1,887.6 kilojoules. So for limiting reactant, your answer is always going to be the smallest number. In this case, think of it as how far you are from zero or how much money you spend. So this one is closer to zero than this one. And I know with negative, it's always like -1 is bigger than -5. But in this case, think of like if you're spending money. Here, you're spending you have withdrawn $1,671 from your bank account. Here, you have withdrawn 1,887. So this is going to be the smaller number. We are losing less energy over here. Okay? Oops. Now let's look at 9. Oops. Okay. So 9 says, how many grams of magnesium sulfate would be produced from the following reaction if 176 kilojoules of energy is absorbed by the reaction? This problem is going to be exactly like number 7, but we just got to take it a step further. Okay, so again, start with what you know. 176 kilojoules of energy. We got to get rid of it. You're going to pick the only other number that has that same unit, which is going to be this. 722 kilojoules of energy. In this, for what to put at the top, look at what they're asking for. Here they're asking for magnesium sulfate. Magnesium sulfate, there's 3 moles in front of it. So you need, for every 3 magnesium sulfates you have, you're going to need this much energy as well. So this is going to be 3 moles of MgSO4. Okay? They want your answer in grams, so you got to go a step further. 1 mole of MgSO4 is going to equal how many grams? Magnesium has a atomic mass of 24. Sulfur is 32. And then oxygen is 16, and you got 4 of them. So 24 plus 32 plus 16 times 4 is going to give you 120. I went a little far on that, but don't worry about it. So you're going to do 176 divided by 722 times 3 times 120. So your answer is 87.8 grams of magnesium sulfate. Okay? And that is it for our review on thermochemical equations. I'll come back and do heat curves soon.